Hello, this is Garrett Keane continuing the series of videos on creating a Telemac model of Shannon. In the last video we created a mesh of average size 300 meters, which is shown here, and you can see that this mesh is very detailed. Now, one of the problems with Telemac is that when you just assign along this boundary here, we're going to assign a tide going up and down. And one of the problems with Telemac is if you use a very fine mesh like this and you only assign the tides without velocities, you can end up getting instability at the open boundary, and the model will then not work properly. One way around this is to actually have a coarse mesh at the open boundary, which will be refined gradually down to 300 here. So what I propose to here is to define four regions here to transition from the open boundary into somewhere here where the mesh is going to be 300. The way we do this is, if I delete this one here, if I remove this one, the way we do it is we come up here and we define a closed line or a polygon. I click on it here and we'll start moving from the inside. We'll start moving from the outside in. So if I define this and I click back up here to close it, and I'll define this line as region 1, and what I'll do is I'll assign the mesh size here of 1500 meters. Then I define another region, and I'll overlap it with this one just a little bit, just to make sure we don't have any gaps, and I'll define this one, and I'll call this one region 2. I'll just close it off by clicking back up here. This is region 2, and that will be, if it was 1500 last time, we'll come down 300, so I'll make the elements here of size 1200. I do another one here. It doesn't really matter, the regions can overlap a little bit. I finish it off here. I call this one region 3, and the last one was, what was the last one, 1200. We make this one 900, and I'll do one more, 1, 2, 3, 4, and I'll close it off by clicking up here. I can then put the name in as region 4, and I'll make this one 600. So you can see here from the open boundary in, we're going to transition from 1500 to 1200 to 900 to 600, and then it'll be 300 all the rest of the way in. So you can see the regions are shown there. This time when we go to do the mesh, we're still going to have a mesh of 300, but this time when I go to do the mesh, I already have this one existing up here, so I have the outline is this outer file here. I'll just do a brand new one, so I'll just remove this one. I won't save the changes, and I'll just do a new one. It's easier than modifying the other one. T3 mesh generator. All the elements inside will be 300 meters, so I'll just say OK there. I'm going to take the outer boundary here as the outline. I'm going to put in these 3 islands here as hard lines, as it was with the last time. Cannon Island, Kenue Island, and Foynes Island. And then what I'm going to do for the density here is I'm going to put these regions in as density maps, or density objects. That means that we defined this one to be 1500, this one to be 12, this to be 900 meters, and region 4 is 600 meters. So when we go to generate our mesh, if we come back to properties, right clicking, and I run here, you can see that it's going to use those density maps to determine the size of the elements in here at the open transition region. So if I say OK, the new mesh is down here, so I just bring it into 2D view, and if we zoom in here, you can see that indeed it does transition correctly. From 1500, if I remove these polygons from view, I can just make them invisible by right clicking them, and switching them off. And you can see here now that we have a nice smooth transition from the open boundary into the inner region where all the elements are 300 meters. Okay, thank you very much for listening. If you go on to the next video, it'll show you how to create a cellophane file, which you'll then bring into Telemac. Okay, thank you for listening.